Hey YouTube, today we're going to talk about how to measure voltage and current in a circuit and why we do it that way. Remember that in a series circuit, currents are the same in every part while voltages are different based on their resistances. However, in a parallel circuit, the voltage of each branch will be the same while the current in each branch is dictated by the resistances. Given this, in order to measure the voltage of a component, we're going to connect across the part, and that will be a parallel connection. Since it's a parallel connection, we will see the same voltage as across the part we're trying to measure. In order to measure current, however, we must break the circuit, physically open it, make a gap. Now we will insert our meter into that gap, and our meter will be in series with the component. Since it's in series with the component, it will have the same current. Let's dive deeper into what's going on here. We want to, in both these cases, attach our meter to the circuit and join the circuit, but we don't want to change the circuit in a significant way. In the case of measuring voltage, the voltmeter has an extremely large internal resistance. 10 million ohms or more is common. Whenever we attach a 10 million ohm resistor compared to our normal circuit resistances in parallel, the 10 million ohms does not affect the circuit in any meaningful way. We are siphoning off a tiny amount of the current, but we are still in parallel, so we still get the same voltage. How about an ammeter for current? By breaking the circuit and placing our meter in line, we are making a series connection. In order to not affect the circuit as we join the circuit, we need an extremely small internal resistance. The ammeter can have 1/100th of an ohm or less resistance internally. Common mistakes. Attaching across parts for a current measurement. If we attach across a part with an ammeter, which remember has an extremely small internal resistance, this is a parallel connection. By adding a tiny resistance in parallel with our intended component, we are significantly altering the situation at that point. This can cause essentially a short and blow the fuse in the ammeter if we're not careful. So do not connect an ammeter across other parts. The key takeaway here is, remember, voltage across the part, and we're attaching in parallel. For current, we must break or open the circuit and put the ammeter in series with the part we want to measure.